right? Well, if you are given an integral something like that, okay, k is a constant, that's easy, right? So this is just like a 1 over x, and right now there's another constant that's okay. So if you let u to be kx minus k, then du is just dx. So this integral just becomes 1 over u du. Okay, then you get natural log of u plus constant. Okay. Natural log of u plus constant, then you let then you change u by replace u by x minus k, and that should be the correct answer. Okay. Now, if you got the copy of the quiz graded by the grader, and if you disagree with his grading of marks, and you can forward the file to me when you write it to me. Okay. Otherwise, I don't know where don't know the details. Okay. So when you write it to me, you think you deserve more credits, you just just forward this file and to my email address. Okay, got it? All right, so whenever in the future, when you see a problem like that, integral of 1 over x minus k, you just simply write down, write the answer. Okay, you don't need to repeat this over and over again. All right. Now, in the last class, we have mentioned this integral several times. Okay, and this integral several times, and there's in the book, there's already a formula there, so you can. This is section 7. I think it's integral of let's go to that section. Okay, so this is inverse of hyperbolic tangent x. Okay, this is an inverse hyperbolic tangent x, right? Okay. And since the inverse hyperbolic tangent x has a formula, can express in terms of a natural log, okay? And then this is a 1 plus x or 1 minus x. Now, here we assume that x is less, absolute of x is less than 1, okay? Okay, this is an assumption. Now, if x is, but x can be greater, right? Can be greater than 1. Then this probably is not the right version. Otherwise, because 1 minus x, 1 plus x are not going to be, you see, if x is greater than 1, the expression inside the radical is going to be negative. Inside the natural log will be negative, so it's undefined. So this is an important assumption. Okay. Now the correct answer should be there should be absolute value similar. Okay. How do we solve this problem? Okay, directly. Well, 1 over 1 minus x is going to be 1 minus x, 1 plus x. Okay. And it's a product in the denominator, right? So I can tell you that this is just 1 over x plus 1 over 1 plus x. When you add them together, the numerator x is gone, and there's a 2 there, so that has to divide by 2. Okay. Now you will ask me, how do I get that quickly? Well, that's very special. I know how to do it, but I'm going to show you step by step in the future how to decompose a fraction we call a rational function, okay, as a sum of several simple terms. Okay, so once you get this, then you can write it in the form. You can put a negative sign here, x minus 1. The reason I want to write it in this form is because I'm going to use in above formula, 1 of x minus k, right? So the integral of this and you will see that it's going to be negative natural log of absolute of x minus 1 plus natural log of x plus 1, okay, and the plus constant. All right. Then you can combine them into one expression, okay, and the plus constant. So the difference between this answer and the above answer is here we have to assume that absolute x is less than 1. Then here's x plus x, here's x minus x. But this one, we have absolute value here, 1 plus x, 1 minus x, is the same, right? So that's the only difference. Then this is defined for any x which is not going to be plus minus 1, okay? As long as x is not going to be plus minus 1 or x squared is not going to be 1, then this is the correct answer. Now, of course, x squared cannot be 1, otherwise 1 over 1 minus x squared is not defined, okay? So this is the best way. This is the best way to solve the problem, okay? And this is true for any x except for 1 plus minus 1. And this method is called, well, the decomposition of rational functions. Rational functions are the functions a polynomial divided by another polynomial. Both are the polynomials. Okay, both are the polynomials. All right, so let's take a look at the next problem. It's 2x minus x squared and the dx. Well, this problem is quite different from the above one, right? Maybe you can try this, okay? It's going to 2x minus x squared. It's going to be 1 over x and then 2 minus, then what? Okay, right? Then what? Can you express it as a sum of some simple terms? Yeah, it's possible. Now, right now, I haven't shown you how to do that, quickly find this part. What I try to show you is, I just separately write to these two terms. I want to check whether I can get, after combine them, whether I can get 1 over x times 2 minus x. I see that when I combine them, the denominator is x times 2 minus x. The numerator will be 2 minus x plus x, just 2. So I have to still divide by 2, okay? Then, in order to integrate, I have to change this to x minus 2, okay? Then, I can evaluate the integral, okay? Okay, I can evaluate integral, then this is going to be half of the natural log of absolute x minus natural log of x minus 2 plus constant. Yeah, put absolute value symbol there. Then you can combine them into one terms, okay? So that's it. So this is true as long as x is not going to be 2, x is not going to be 0, okay? Yeah, otherwise, 2 minus 2x minus x squared is going to be 0. Another way to solve this problem is use substitution, okay? 2x minus x squared is going to be negative x squared minus 2x. So I don't like two terms that contain x. Okay, I should get x squared minus 2x plus 1 and minus 1. This is called completeness square. Okay, that is going to be x minus 1 squared minus 1 And after combine them, get rid of parenthesis, I get 1 minus x minus 1 squared. Right, so that's called a standard form for the quadratic function. Then the integral of 2x minus x squared dx is going to be the integral of x minus 1 squared dx. And clearly, you can use a substitution. Let u to be x minus 1. Then du is just dx, so it's the integral to 1 minus u squared du, and that's what the standard form, right? So using the above formula, remember what we got. We got 1/2 natural, 1 plus u, and 1 minus absolute value plus constant. Don't forget absolute value. All right, so u plus 1 is just x. And the 1 minus u is going to be 2 minus x. So you get the same answer, okay? Yeah, u plus 1 is going to be x. 1 minus u is going to be 2 minus x, okay? From above substitution. You can see that. Right, so you get the answer. Okay, so you needed to memorize this integral. Well, you don't need to probably don't need to memorize, but if you memorize it better because you are open book test, right? You're doing open book quiz. But you still have to search for the page. Okay. But yeah, about the quiz, I said that if you think you deserve more credit, and you already got a copy from the grader was his marks, and you just send that copy to me as attachment, and write a few words there, okay? And I will double check for you, okay? Right, so our next problem, yeah, for practice, let's try another problem, okay? So this is going to be the integral of x squared minus 6x dx. Okay, you can try this. Okay, how do you do this problem? There are a couple ways to do. One is you can directly write as product as a sum of two terms, right? You can fact it. The question is, what are those two terms you have to put there? It's not easy to figure it out. Okay, what I'm going to tell you is this is going to be x minus 6. It's minus, not plus. Okay, if it's minus, then I will get, okay, yeah. So either way, if you choose put a minus 6 here, and then the other one should be positive. Other one is just x, yeah. Okay, that's okay. Then when you combine those two terms, you will get 6 in the numerator. So you have to divide by 6. Okay, because x minus 6 is going to be 6. That's why I divide by 6. Okay. Then you get you can evaluate integral for each term. Okay. So we know that this is the absolute value of x minus 6. This is absolute value of x and plus constant. Okay. And that's answer. You can put them together. What I really wanted to do is trying to use a substitution and convert it to the standard one. Okay, so x squared minus 6x is going to be x squared minus 6 plus half of the negative 6 squared and minus half of it, right? This is identity, either one and minus one, the same number. Okay. Then you get x minus 3 squared and minus 9. Okay, So your answer will be, so you will get x minus 3 square minus 3 square minus 9, doesn't matter, right? Dx. So here you use a substitution, you will get u square minus 9 du. Right? Now, if we want to use a formula, then you have to use another substitution in order to get rid of 9. So what I'm trying to do is I'm going to put 3, x minus 3 is going to be 3u, okay? So then I get 3 squared, then I get the same constant. Okay, so x minus will be 3u squared, right? Then I have a 3u squared, so it's 9. Okay. Then 3 du is going to be dx, right? So dx is going to be 3 du. Okay, right? So after it's simplified, you get, this is what we want, right? And but in our formula, it's 1 minus u squared. So I have to change it to the standard form. Then I can apply the formula. It is going to be absolute 1 plus u, 1 minus u. That's what I remember, right? Then you replace u by x minus 3 over 3. And of course, you have to simplify. You have to simplify. So you get, after you simplify, 3 plus x minus 3 is x. And the 3, it's a 6 minus x plus constant. All right. So that is our answer. Now, why there's a negative 1, 3? Did I make mistakes here? No. This is what we got here, right? Well, there's mistakes here. Let me double check. All right. So we have to double check, okay, why there is a difference, okay? So this is clear, right? 1 of x minus 6 minus 1 of x, okay? Add them together. X is canceled out. That's why you have to divide by 6. Okay. You have to divide by 6. Okay, so this should be the answer. X minus 6 is on the top. It's a 1 over 6, not a 1 over 3, right? So here, yeah, okay, yeah, we have, there was a mistake here. Actually, this integral is going to be, that's 1/2 of that. That's why it's going to be 1 over 6. Okay, okay, that is correct answer, okay? So it's the same answer we got. So double check. So this integral is going to be 1/2 of natural log of 1 plus 3 over 1 minus 3. All right. All right. So what is I know sometimes it's difficult to decompose the function into rational function into the sum of simple fractions, usually as reciprocal of some linear terms. So what is a standard way to do that? Okay. For example, if I have an x minus 2, x plus 4, can I express this like x minus 2, here's x plus 4, whether I should decide to use a plus or minus? Okay. Well, the numerator you should get a constant, so that's why you have to use a minus, because then x plus 4 minus x minus 2, that is numerator, which is going to be 6, right? So in order to make it 1, you have to divide by 6. So I see I can quickly find the decomposition. Right? Yes, the reason I choose a negative sign here and minus sign is because I want to get rid of x. And when I combine them. Okay. So if you can do this way, then you can quickly get the answer. It's integral 1/6, and the first term is going to be natural log of x minus 2 and minus natural log x plus 4 and the plus constant, right? Okay. But if you say, well, I don't know, it's not trivial. For example, how about x plus 5 here? Then what? Okay, then what you can do? It's very difficult to get 2 terms. Okay. Yeah, it's better to find the standard method to determine the sum of some simple terms. So we can try like this: a over x minus 2 and b over x plus 4. So we're trying to determine the coefficient of a and b. Okay. Right. So you combine them again. So I get x plus 4, here b, x minus 2. So the numerator, the linear term here is ax, right, and plus b. And here 4a minus 2b, okay? So you want to match it with a term on the left-hand side. So that means a plus b should be equal to 1. And 4a minus 2b should be equal to 5. Definitely you can solve equations to get a and b. Okay? So how do you solve this equation? The elimination method and the subtraction method, right? I cannot eliminate the number by adding 2 equations together. So what I'm going to do, there are a couple ways to do. I can multiply the first equation by 2. That's called the 1 prime modified equation. Then 1 prime plus equation 2. And now we'll see that 2 plus 4 is 6a, and then minus b, 2 plus b is gone, and 2 plus 5 is 7. So the a is going to be 7 over 6. Right? So once you get a, then you can use the first equation, get a b. b is 1 minus a. And the 1 minus 7 6 is going to be negative 1 over 6. Okay? So you get 2 numbers, and that tells you, okay, here's x minus 2, x plus 4 is going to be 7 over 6, x minus 2, minus 1 over 6, x plus 4. Okay, it's guaranteed. It's decomposing into those 2. All right, then you can evaluate the integral quick. Okay. The integral of the first term, 7 over 6, natural log of absolute value minus 2. The second term, and the plus constant, right? So that's it. Well, I don't know whether you want to, you can put them together. So that will be x minus 2, 7 over 6, and x plus 4, 1 over 6. It's not a big deal. That's not simple. So that's enough. Okay. Right, so let's take a look at this following problem. 3 minus 2x minus x squared dx. What is the best way to solve this problem? For an quadratic function, right? They are, let's put a negative sign outside, okay, plus 2x minus 3. I can do two things. One, the first thing I can try to express in the standard form. So that'll be x minus 1 squared minus 1 is minus 4. Okay. Completeness square. Okay, just add 1 minus 1. Okay. Then x squared plus 2x plus 1 is x plus 1 squared. Then minus 4. So so you can use a substitution to convert above integral into the standard one. Okay. So substitution, you have to let u to be, I think let the u is going to be half of this. 2u is going to be x plus 1. Right. And then you have 4 minus 4u squared, right? So 2 du is dx. Okay. So the above integral is going to be 4 minus 2u squared, right? X plus 1 is 2. And the dx is 2 du. Okay, so there's a 4 out, taking 4 out, it's 2 over 4. Okay, that's a standard integral, right? So you know the answer. Okay, don't forget this time divide by 2. Okay, so it's going to be natural log of 1 plus u over 1 minus u plus constant. Then I replace u by half of x plus 1. And you have to simplify a little bit. I got 2 plus x plus 1 is x plus 3. 2 minus x minus 1 is 1 minus x. So that is that. Okay. That's one way to do. The reason I can do this is because there's nothing in the numerator, just only 1, constant 1. Okay. Then you can, as long as you convert it to a standard form of the denominator into standard form for the quadratic function, then use substitution, you can change the whole fraction, change the integral into the standard one, like 1 over 1 minus x u squared du. Okay. But if the numerator is not just single constant, you cannot do that. Okay. So what is the standard method? So 3 minus 2 minus x squared, and this is going to be, I take a negative sign out. I don't like the negative sign. So you can factor it. It's x plus 3 and x minus 1, right? Okay. And then 3 minus, then you should be able to decompose. Yeah. 1 over 3 minus 2 minus x is going to be negative x plus 3 and x minus 1, right? You can express it in the form x plus 3 and v x minus 1. So you just determine the coefficient. All right, so let's try. Yeah, you can, I already figured out what is that. If you can determine the constant, okay? No problem. What I do is I just directly, I can write this, and I think I'm going to get rid of x, so I have to, one of them must be minus, okay? So this is x plus 3, x minus 1, it should be minus, okay? Then x plus 3 minus x minus 1, right? X plus 3, that's numerator, x minus 1, that's 4. So I have to divide by 4, okay? So you can get rid of the numerator. Now, if you combine those two terms and then determine the constants a and b, and you still end up with the same answer, okay? So then the integral of 3 minus 2x minus x squared is going to be negative 1/4 natural log of 3x minus 1, natural log of x plus 3, and plus constant, okay? So which one shows at the bottom, because there's a negative sign here, right? This should be on the top. This should be at the bottom. Right. And that is answer exactly what we got here, right? Exactly, yes. Same answer. I want you to try this now problem. What it changes is the numerator becomes x plus 2. So in this case, there's no quick way to get to the decomposition. So what I still get here is x plus 2 minus x plus 3, x minus 1, right? So I can claim, I can express in this form, okay? So I would like you to try to determine the constant a and b. I give you half, 1 minute, yeah, just 1 minute, okay? You try this, okay? All right, I hope you figured out the constant. So let's try, okay? So we already get the above expression. If you combine them, you get A x minus 1 plus B x plus 3, and here x plus 3 and x minus 1. Be careful, there's a negative sign at the bottom. So A plus B x and plus negative A plus 3B. You compare both sides. I think there's a negative sign here. You should be careful, okay? So that means A plus B should be equal to -1. Negative A plus 3B should be equal to -2. Yeah, don't forget the negative sign, otherwise there's some mistakes. Mistakes. All right, that's equation 1, that's equation 2. All right. So adding them together, I get 4B equals -3, so B equals -3/4. And then I get A from the first equation. A equals -1 minus B. -1 minus B is 3/4. And that is going to be -1/4. Okay. All right, so you get A and the B, and then you get decomposition of this 2, right? Yeah, 3 minus 2x minus x squared is going to be -1/4 x plus 3 minus, yeah, you can say plus. Okay. Right. All right. So the integral, right? If we put the integral here, and then you get the integral here, right? So you get -1/4 natural log of x plus 3, and then -3/4 natural log of x minus 1 and plus constant. Oh, this is answer. All right. Of course, there are other ways to solve this problem, but let's stop here and move on to next one. So what happens if you increase the numerator, the degree of the numerator? Okay, so if I change this problem to x squared, okay, and I multiply it by x, right? So 3 minus 2x minus x squared dx, then what? Now, in this case, you may, of course you say, well, I'm going to factor the denominator. But I want to say that x squared plus 2x, 3 minus 2x minus x, yes, this is going to be negative, x plus 3, x minus 1. But there's no way you can express it in this form. Okay, no. Okay, that, you can try, but you never get a quadratic. You never get a x squared in the numerator. Remember, right? When you combine those two terms in the numerator, right? You only get a linear term. You don't get a x squared. That's why there's no way you can decompose it as a sum of two simple reciprocal of the linear terms. Okay. Yeah, the reason is, you see, you get ax minus 1 plus bx plus 3, right? You don't see x squared. You don't create x squared there. So it's never been. But can we still solve the problem? The answer is yes. So what we can do is, if the degree of the numerator is greater than or equal to the degree of the denominator, you have to use a long division, okay, to simplify the fraction. So what you're going to do is you put a negative sign here, -1. So I get x squared plus 2x minus 3, and take a subtraction, I get 3. Okay. So that means x squared plus 2x is going to be -1, the quotient, times this, and the plus 3. Okay. Yeah, remember, if you have a polynomial f of x divided by px, you get a quotient, and then you get the remainder. The relationship is f of x divided by px, you get a quotient, but the remainder is still in this form. So if you both sides multiply by px, you will get px qx plus ix. Okay. So once you know that, then you can x squared plus 2x over 3 minus 2x minus x squared is going to be -1, plus 3 minus 2x minus x squared. Okay, that's what we need. Okay, then you try to figure out how to evaluate this integral. Okay. And then we already know that this is going to be 3 here, x plus 3, and x minus 1, right? And I know that decomposition. I think I'm going to put, yes, this is going to be x plus 3 minus x minus 1, no, plus 3 minus 1. How about that? Okay, yeah. Okay. Then the numerator, I get a 4. Divide by 4, then I get 1 of x minus 1 times x plus 3. Okay, so we already get this above, so I just mentioned that. Okay, all right, then you can evaluate the integral. Yeah, then you can evaluate the integral x squared plus 2x, 3 minus 2x minus x squared dx. The first one, -1, I get -x, minus 3 over 4, natural. Okay, so that is answer. So the idea is that you have to decrease the degree of the numerator. Okay, if the degree of the numerator is greater than or equal to the degree of the denominator, you have to use a long division to simplify. You have to use a long division to simplify. Okay. Now, this is about, essentially, it's about the integral of 1 over 1 minus x squared. We also know that integral 1 over 1x plus x squared, right? This is going to be the tangent x, inverse of tangent x. Okay, right? I cannot, yeah, compare with this, right? It's called the inverse of a hyperbolic tangent. So we already did that for this one. Then how about 1 over 1 minus x squared? Okay. Well, if I still go back to the original problem, but this time I change everything to positive sign. Okay, 3 plus 2x plus x squared. Okay. So how can I do that? So x squared plus 2x plus 3 is going to be x squared plus 2x. I had to add 1, subtract 1 plus 3, right? And I get x plus 1 squared plus 2. Okay. So the integral becomes That's very similar to like a 1 plus x squared. So I have to use a substitution. What kind of substitution we can use? I think I'm going to make x squared plus 1 to be square root 2u, because then you squared x plus 1 squared get 2u squared, right? Then 2 cancel out. So that's what I want to do. So dx equals square root 2 du. Okay. Then I get 2u squared plus 2 and square root 2 du. Okay. Okay. Finally, I get a simplest integral in which I can use a formula. I have to replace u by x plus 1 over square root 2. Okay, so this is the answer. How about, same idea, I'm going to increase it. Okay, I'm going to increase it. Make it easier, I can put 5 here, okay? dx. So I can change it to 1, okay? It's not a, yeah, I just want to make it a little bit easier. Let's change it to, okay. Yeah, otherwise I have to get some constant. So it's plus 2. All right, so what am I going to do next step? So first of all, it is going to be x plus 1 square, and then plus, I think of just plus 1, right? After completing square. Okay, if I put the 5 there, then you have a 4 here. It's okay. So you let u to be x plus 1, so du equals dx, right? And then I get u squared plus 1. How about the numerator? Numerator is x plus 3. So if it's u, so use x plus 1, right? So u plus 2 is going to be x plus 3, right? So u plus 2. And dx becomes du. Okay. Now, how can we evaluate this? Well, I have to separate. Then you can solve the problem. Okay. The second part is just 2 tangent inverse of tangent u plus constant. The first one, you have to use substitution. Okay, actually it's going to be natural log of u squared plus 1 divided by 2. Okay, when you differentiate, you get 1 over u squared plus 1, then you times 2u, then you have to divide by 2. So I would do this problem, okay? But this is the answer, okay? This is the answer. Then you replace u by x plus 1. All right, so for integral like this, there's a typical substitution you can choose, right? So u squared plus 1 let the dw to u squared. So dw equals 2 u du. Right. This is going to be integral, right? It's w. U du is half of dw, right? Yes. And then that's going to be natural log of absolute W plus constant. W is U squared plus 1. So there's no need to put the absolute very simple there, okay? How about x squared plus 2x plus 2? You have x squared plus 3x plus 5 and dx. Yeah. Again, right? We see that it's a polynomial, the degree, the numerator, the degree of the numerator is 2. 2 is greater than or equal to the degree of the denominator. So you have to use a long division to reduce the power of the numerator. It's 1. X squared plus 2x plus 2, you get x plus 3. So what does that mean? That means this integral is going to be the quotient, and have x plus 3 and x squared plus 2x plus 2 dx. Okay? And so you just need to evaluate this integral. And I think we already did that. That's the reason I choose that number, okay? So x plus 3. So we already solved the problem above, otherwise just repeat it, okay? So you got, oops, sorry. Yeah, the first term is x. The second term, the integral we got, it's here. You see, just copy it, otherwise you repeat the whole procedure. Okay. 1/2 natural, right? 1/2 natural, and actually inside, if you multiply this out to this, and plus 2 arctangent, okay, and this will be x plus 1. All right. Yeah, we did we already got, evaluate this integral. So what we did is just to reduce the power of the numerator by the long division. That's the first step. If the degree of the numerator is greater than or equal to the degree of the denominator, then you can do this. Now, some students maybe ask, what happens if I have to deal with something like that? Okay. And in the book, they already show you what kind of decomposition you're going to get. Okay, so decomposition you're going to get must be in the form like that: ax minus 1 and the bx plus c x squared plus 1. So the second one, you can use a substitution. It's easy to evaluate as long as you determine the constant like that, and then the integral. Yeah, this part of the integral is okay, right? And you actually have 3 terms here. Okay, and you know how to evaluate each of the integral. Then you can solve the problem.